we have a question here that says we've got a spherical balloon. So we've got this spherical balloon and it's got a radius of r, okay? And it's increasing at a rate of 5 centimeters to the power of 3. So it might be a little bit difficult because of the pixelation there, but the rate at which the volume of this balloon is increasing is at a constant 5 centimeters to the power of 3. So find the rate of increase when the balloon equal to is equal to 4 centimeters. So we can say that our volume, all right, so our volume is going to be equal to, you can look this up on your data sheet, but it's just this, 4 divided by 3 pi r to the power of 3. So we're saying from the question that our volume is increasing at a constant rate with respect to time. That's the key one there, to time. So there we go. So it's equal to 5. And so you can either write it out all nicely or you can leave it as that. So unfortunately, we've got this thing with respect to time and we've got this other equation with respect to radius. So we're going to have to do a little bit of trickery, I guess. So what we need, okay, is that this, when we differentiate this with respect to time, let's say we've got v, and we differentiate it with respect to time. That's okay because that can just be equal to dv dt. That's cool, right? That's when we say it's equal to 5. But if we scroll a little bit further down and we try and differentiate with respect to time, our 4 on 3 pi r3, there's no t in there. What? So it becomes a composite function, and we need to use the chain rule. So we differentiate this with respect to the radius first. So it becomes equal to d dr of just all the stuff that's equal to r. Okay, but then we need to times by whatever's in the inside because r is equal to something, I don't know, times by t, right? So then we need to figure out what dr dt is. And that's the other term that we've got to multiply it by. So times by dr dt. Perfect. We can do the first bit, and that 3 multiplies down, okay? So that 3 multiplies across there, and then it goes from being a 3, we take 1 away from the top, so it becomes a 2. And then that we multiply by dr dt. Now all of this is equal to dv dt, and we know that that's equal to 5. So now we have an equation. So we know that at this point, so when the radius is equal to 4, okay, so our r value is now got a constant in there, right? So we can substitute it in. So find dr dt. That's what we're trying to find here. So find dr dt when r is equal to 4. So hopefully I'm going to draw out the entire equation again, but this time I'm not going to have any of the dv's or anything in there. So it's 4 pi r squared times by dr dt. Now, I don't know about you, but it gets really annoying to try and solve for something that's a fraction. So I'm going to make life easier, and I am going to put it like this. We're just trying to solve for RT. You can do that, right? This time as well, this is equal to 4 to the power of 2. So let's simplify everything. So 4 times 4 is 16. So times by 4 again is 64. And now we can solve for it. We can solve for that. RT is equal to 5, all divided by 64 divided by pi there. And that is our final answer. Now, quite tricky, right? With the understanding that it's in different units and then using the chain rule. So this is like a good question to get used to. And I've got plenty more of questions like this. So reach out via comments or email if you have any questions. Otherwise, go to the description, the video description, and there will be a link to the website with plenty more exam questions like this.